Now that we have seen angles measured in both degrees and radians, I would like to present two definitions that we can use to relate different angles together. The first definition is coterminal angles. Two angles are coterminal if their terminal sides coincide, basically meaning they end at the same point in the quadrants. For example, you could consider a positive angle of 30 degrees and imagine another angle that performs a whole revolution around the circle, comes back to this same point. That angle would be 360 plus 30, so 390 degrees. These two angles are considered coterminal. They end at the same place in the quadrants. I should also mention here that we can measure negative angles. Say I consider a positive angle 135 degrees. That's measured counterclockwise from the positive x-axis. I could also describe the same point by measuring clockwise from the positive x-axis. This would be a negative angle, and this would be negative 225 degrees. So negative 225 degrees and positive 135 degrees are coterminal angles. So we can find coterminal angles simply by adding or subtracting 360 degrees. That moves us one revolution around the circle and gets us back to the same place. Or if you're working with radians, adding or subtracting 2 pi radians. For example, if I want to find a positive angle and a negative angle coterminal with 45, I can take 45 degrees and simply add 360 degrees, and I get a result of 405 degrees. Or alternatively, I could take 45 degrees and I can subtract 360 degrees. This is moving once around the circle in the clockwise direction. I get negative 315 degrees. So all of these angles are coterminal. 45 is coterminal with 405 and also with negative 315. And in theory, I could create an infinite number of larger and smaller angles that are coterminal with 45. It's usually helpful to think of angles between 0 and 360 degrees, or 0 and 2 pi radians. So if I see a negative angle, I might add 360 degrees to it to make it a positive angle between 0 and 360. Or if I see a really large angle, I might subtract 360 degrees from it to make it lie within the range 0 to 360. The second definition I'd like to cover is reference angles. This becomes very important as we evaluate trigonometric functions later on. The reference angle for any given angle is the smallest acute angle between its terminal side and the x-axis. So let's discuss that in a couple of different quadrants. It looks different for different quadrants. If you're in quadrant 1, the angle itself, the angle measure theta, is also the reference angle. That is the smallest angle between that terminal side and the x-axis. However, if I measure an angle in quadrant 2, this angle theta is a quadrant 2 angle. The reference angle is this part. This is the reference angle, the smallest acute angle between that terminal side and the x-axis. And if I'm in quadrant 2, I can find the reference angle by taking 180 degrees and subtracting theta. Or if you're working with radians, pi radians minus theta. In quadrant 3, say I have a quadrant 3 angle, this is the reference angle. And in quadrant 3, I can find that reference angle by taking the angle theta itself, which is a quadrant 3 angle, and subtracting 180 degrees. Finally, in quadrant 4, this is the reference angle. It's the smallest acute angle between that terminal side and the x-axis. In quadrant 4, I can take 360 degrees minus my angle theta to find the reference angle. The reference angle is always a positive angle, and it's always less than 90 degrees or equal to 90 degrees. This will be important as we evaluate trig functions later on, because the trig functions for an angle and its reference angle are always the same, with a possible difference in positive or negative signs. So let's try to find the reference angle for a couple of examples. Say I want to find the reference angle for 2 pi over 3. It may help to decide where that angle is located in the first place. Is this a quadrant 1, quadrant 2, quadrant 3, or quadrant 4 angle? This angle is located in quadrant 2. If I think about this as being pi radians, we could also say that's the same as 3 pi over 3 radians. So 2 pi over 3 radians is about 2/3 of the way there. 2 pi over 3 radians is about right here. What is the reference angle? This is the reference angle. And we can find that by taking 3 pi over 3 and subtracting 2 pi over 3, and we get pi over 3. This is the positive angle between 0 and 90 degrees. That is our reference angle. Second, I want to find the reference angle for 315 degrees. This one in degree measure is a little more intuitive to locate. This is an angle measure in quadrant 4. And the reference angle here is this acute angle between 315 degrees and the x-axis, which we'll call 360 degrees. So what is the reference angle in this case? It's 360 minus 315. It's always a positive angle, which equals 45 degrees. Here's our reference angle for 315 degrees.